Next, let's look at the math class, capital M, that contains some functions or methods for doing mathematical operations. So you call the functions and methods on the class object. You say math dot cosine, math dot random. Functions that are attached to objects like this, to classes like this, are usually called methods, as opposed to functions, which are general top-level functions and aren't attached to objects. If you've done real object-oriented programming languages like C# and Java, you may be used to calling these static methods. It's the same basic idea. The other thing to note, first thing to note is you say math dot, whatever the method name is. The second thing to note is that this uses the scientific versions. So the logs by default are base E, and the trig functions like sine and cosine are in radians, not in degrees. So there's a whole bunch of functions. ABS for absolute values, sines, cosines, tangents, minimums, maximums, rounds, sines, square roots, tangents, random, and so forth. I'll give some interactive examples of the most important ones. And then there's some constants defined as well. There's e, the square root of 2, the square root of 1/2, there's pi, and so forth. Notice that with constants, the values are capitalized. That's a convention, but not a requirement. And the built-in constants all follow this convention. All right, this kind of sounds reasonable on paper. Let's try it in practice to see how it works. Okay, let's first illustrate the point that it's using the scientific versions. In particular, the trig functions use radians, not degrees. So if I say math, capital M dot cosine, lowercase c of math dot pi, I get 1. If I do cosine of 0, I get 1. The ABS operation is quite common. It means absolute value. So math.abs of 2 is 2, and of minus 2 is also 2, the absolute value. So this is quite useful in real life. Math.round is useful in real life. 1.3 rounds it to 1. But what about 1.5? What does that round it to? I get 2. What about 2.5? I get 3. So math.round, if it's exactly in the middle, rounds up, like some languages, but not all languages. Square root is also quite useful. It's SQRT. So math.square root of 100, of course, is 10. But the thing to realize is that the representation inside computers only has a certain number of digits. Double precision has a certain number of digits. And so if I say math.square root of 7 times math.square root of 7, well, if I take the square root and I square it, I should get back to 7, right? Well, maybe not exactly. And I get one little extra digit way down here because of round-off error. So be aware that if you take the square root of something and then you square it again, if the square root was a decimal number, not a whole number, and you square it again, you might not get back to exactly where you started from. POW has to do with exponentiation of power. So math.power 2, 3 means 2 to the third power. 2 to the 3, 2 to the 4, 2 to the 5, and so on. And last but certainly not least, math.random returns a decimal number, a floating point number, a double precision number between 0 inclusive and 1 exclusive, hopefully evenly distributed across that range. So if I run it a bunch of times, I should be equally likely to get any floating point number in the range from 0 inclusive to 1 exclusive. Math.random is very useful when you're learning and practicing so that your code doesn't run the same way every time.